say D all day.
We have already touched on a bit how the GMAT likes to use exponents to test your knowledge of number properties, such as your even and odd number properties, your positivity and negativity number properties. So let's take a look at a problem doing just that. This says if a times b times c times d is not equal to 0, and a times b squared times c cubed is equal to d to the fifth, is d to the fifth greater than 0? So if a times b times c times d is not equal to 0, that means none of these can be equal to 0. So a, b, c, and d, none of them are equal to 0. And therefore, if I were to rewrite out this expression, so this is the information they give us, and note when I do that, I like to make very liberal use of parentheses, because I like separating out my terms as much as possible, because that is how I can visualize patterns. That is how I can get things to stand out, especially when they present the information in this jumbled, sort of clustered form. So this is what I know. A times b squared times c cubed is equal to d to the fifth. So if they're asking is d to the fifth greater than 0, that's really the same as asking is a times b squared times c cubed greater than 0. So what do I know about a times b squared times c cubed? Well, to start, I know b squared must be positive, because b cannot be 0. Therefore, b squared must be positive, because anytime you square something, your only choices are you either have something that's positive or something that is equal to 0. So if I'm looking for the sign of a times b squared times c cubed, then the only things that are really determining that sign are a and c cubed, because b squared is set. That is positive. So if I want a times b squared times c cubed to be greater than 0, well, there are only two ways I can get something greater than 0 if I'm multiplying things together. You can either have a positive times a positive, or a negative times a negative. And so this whole question here is, so if I really want to know is a times c cubed greater than 0, because a and c cubed are the only things that determine the sign of d to the fifth, because the b squared is sort of set. It is irrelevant. And so that means either a and c cubed have to both be positive or both be negative. And so if I wanted to, I can rephrase this question as, do a and c cubed have the same sign? But if I wanted to put everything in terms of just a and c, when I have an odd exponent, like I do here, the overall value of the exponent just retains the sign of the base. So this is really saying, do a and c have the same sign? Because c cubed is just going to have the same sign as c. So if I wanted to rephrase my question like that, do a and c have the same sign? Because my question is asking, is d to the fifth greater than 0? D to the fifth is equal to this whole thing here. I know b squared is positive, so the only way to get a value greater than 0 is a positive times positive. So a and c cubed, a times c cubed needs to be positive, which means either a and c cubed are both positive or both negative, which means a and c have to be both positive or negative. That is how we got from here all the way to here. Now let's look at our statements. Statement 1 says a times c squared is greater than 0. So if something times something is greater than 0, again, there's only two ways that can be true. We have a positive times a positive, or a negative times a negative, but c squared must be positive. So this is not possible. So if I'm thinking, what is this telling me? Even though c squared must be positive, c can be positive or negative. So this is really just telling me something about a. This first statement is just telling me a is positive, a is greater than 0. I need to know something about a and c, so I'm a little bit closer, but even though it might look at first glance like the statement is telling me something about c, it is not, because c squared does not really sort of masks the properties of c. C can still be positive or negative, so insufficient. Statement 2 says c times d is greater than 0. So what does this mean? So off the bat, you can kind of say this is going to be insufficient, because I need to know information about a and c, and at most it looks like this is going to tell me something about just c. And so my only options here are c and d are both positive, or they're both negative, but I don't know anything about a. And so Statement 2 is going to be insufficient. So now if I'm looking at them together, so I still want to know, is d to the fifth greater than 0? So I rewrite out my original piece of information. This is positive. So I'm looking at them together. So now I know a is greater than 0. So this here is positive. And now here, it looks like this guy's statement 2 is telling me c and d must have the same sign. And so there's only two possibilities for c cubed here. C cubed is either going to be positive or it's going to be negative. And so what I want to do here is I just want to see if what statement 2 is telling me is c and d have the same sign. Well, do each of these give me the same sign for c and d? Because both of these are raised to odd exponents. So if c cubed has the same sign as d to the fifth, that means c has the same sign as d. So here, we got a positive times positive times positive, which means d to the fifth is going to be positive. Here, we got a positive times a negative, which means d to the fifth will be negative. So in each of these cases, c and d have the same sign. And note, in this case, c is positive, c is negative. And so in terms of answering our question is, do a and c have the same sign? So what do we know? We know a is positive. But in this case, c is positive. In this case, c is negative. And because both of these fit the requirement of statement 2, that c and d have to have the same sign, this is insufficient because in this scenario, a and c have the same sign. So let's say yes. And here, a and c have different signs. So that gives us a no. Once you have a yes and a no to your question, that makes it insufficient. And so E is our answer choice here.